last reInvent, I guess. Yeah, just before it, maybe. This reInvent. And it was actually...
1, 2, 3.
Yeah.
Last reInvent, then they announced it, but they were working on it for like a couple of years in secret.
Yeah. For me, like, I don't know if you agree, but for me, it is like it was the most exciting announcement since Event Bridge for me. Like to see that like some truly serverless relational database.
If you remove all the AI stuff, then you're left with a couple of things, and the DSQL was like the top thing that was. It's something that promises to be truly serverless.
Exactly.
In a pure church of serverless way.
Yeah.
Like that was preached before. So no CPU, no, you don't have to think about anything. They will deal with that.
Exactly. So as we are the Baptists of the serverless church, we got really excited when we see the Aurora DSQL, and it was like when we are receiving a lot of Gen AI talks, I was like already losing my patience. And hey, like we need a DSQL talk. Like we need someone to talk about this because it's really the important one.
Because where will that knowledge base be? Like it has to be somewhere. Like it's S3 in OpenSearch or database. Like if they think that they will remove databases, they are.
Good luck with that.
Good luck with that. Yeah.
Goran reached out to me about like, hey, I can actually do that, and I said, just come over. And like he came from Serbia for this talk, and we are super happy to have you here, Goran, another time.
You know that I'm very open with AWS. If I don't like something, I say that. So if you want to stop me, it's time to say that now.
So like our police is here. So like if you want to just like while you are telling something, you can look at Usman and then say like am I allowed to even say that? But like
this is like AWS police or like that's why I only come to AWS Community Days. That's why I don't go this corporate stuff.
Like I should say this, like AWS, I think you would also agree that like AWS takes every criticism with a lot of the care, and then they are really caring what we say. Like no matter which tone we are saying it. I'm very happy that like the reactions that we are getting from AWS whenever we say something
I'd say that
bad about them. But
they called me to become an AWS hero because I was saying so many bad things about Aurora at some point of time. Like I was so criticizing them so much, so they wanted to shut me up. So they called me to become an AWS hero. So yeah, it had some kind of another effect. I got deeper into that. I went into deeper conversations with smart people like you.
Yeah.
And when you realize how much work goes into a product like Aurora, then you start to really appreciate that. Because it's just like another database. Yeah, okay. So, but then, like there are so many kind of base services that they need to create in order to build such a product on top of these things. Like a storage, like a journal, or like things like that. So. I think the biggest problem these days is that AWS is promoting more this AI stuff instead of really great things that they do. Like for example, this Aurora serverless V2 scaling up and down. These things are so fundamental that they can really change the way that all AWS services that use data will move in the next 5 years.
Exactly.
So
yeah, let's talk about those great things, and I'm leaving it to you. Thank you.
Yeah. Okay. Okay, guys, I have like 25 minutes for this talk, and this is not enough. So if you have to take something from this, is that this is a great product. I was disappointed a couple of times, for example, with Aurora Serverless V1. Then with Aurora Serverless V2, I was really excited with the product, but I was not excited with the pricing that they made. And I like this product so much that I would say that I will forgive them if it's expensive, okay? Okay, so the big problem now is that we don't know how much it will cost because it's in preview. So I'm talking about the product which is not finished yet. It will become better. There is a capacity in technology that they use to make it better. And if we really get what they promise, it's going to be one of the fundamental services of AWS. So, let's start. So what's a database? Has some kind of compute. has some kind of storage in memory, and it has some storage on disk. Memory is limited, disk is kind of unlimited, disk is slow, memory is fast. Okay, we don't have these things. If someone solves this, like I don't know, Optane tried to do that, one day, if all these things become really cheap and fast, maybe we can solve some other level of issues with databases, but in this life, probably not. So what we're having now is that when we have to, when we have some data, we have to move it back and forth between like a temporary memory, closed storage, to the far distant, cheap, endless storage, like a hard disk or something, whatever. So this is the reality now. There are some logs in between, just to keep things safe, so we can maybe recreate stuff on failure. But that's it. That's a typical relational database these days that you can run on your machine in this setup. Okay, this is kind of slow. So what AWS has in the pocket these days? What are the services they have now? First, they have Aurora RDS. It's a service that is very close to what I just talked about, except that it runs in AWS, managed by AWS, in terms that you say what kind of a database you want, what kind of a CPU you want, and how much storage, and you get it. Okay? Storage is not this cheap storage, let's call it. It's not on your local machine. It's on a network through EBS service. Okay, so it's very fast. It can be super fast. It depends on how much, which type of service you choose. But that's pretty much the same configuration that we had with our local machine. So the next level that they have is Aurora. There's like a, I don't know, like mixed issues with these namings, but let's call this like a standard Aurora, in which they decided, okay, we need to remove this whole disk thing, like the way we approached it so far to that problem. And they made some really new storage, which is actually a bunch of new servers that receive logs and then recreate stuff and copy these things on like 6 copies, whatever, you know. So storage is separated in a way that it's not like a typical network storage. It's a journal. You send logs, and then the storage decides how it will keep it. Okay, so it's a smart storage. Okay, it can process things and decide what it will do with these things. It's not a typical, let's say, disk. Okay, and Aurora brought us some really great things. You know, we got replication to other machines with almost no lag, which is pretty unheard of. You know, like it's so hard to achieve these if you make your own network, to get 15 replicas, read replicas of a single machine with almost like I don't know, 20 milliseconds, 10 milliseconds, whatever milliseconds, you know, we're talking about. So you can really scale in a way that you can have many read copies. Eventually, but okay, 15 milliseconds, 20 milliseconds, it's not that eventually, you know, it's pretty much close to actual writer master machine. So Aurora was a revolution. It's 10 years since Aurora was announced, and it was like the fastest growing product that AWS had, because it is hard to run and operate your own database. That's why people liked it. And one of the biggest things, the best things about Aurora is that it was available in MySQL and then later in Postgres version, but it didn't require developers to change what they already did before, which is a major thing. You know, just you can move to the cloud and use the same open source database that you had before. Okay. You will notice that when AWS makes another database like DynamoDB, which is a great database, it's so hard to use it. you go to university, you learn about SQL, you learn about relational databases, relations, you make tables, you do denormalizations, normalizations, blah, blah, blah. And then so all of a sudden you have to learn completely new stuff. And your current applications cannot be moved to Dynamo. They need to be reprogrammed to work with Dynamo. Okay, so Aurora made the first really, made your jump to the cloud very easy. So I jumped, I enjoyed it, but I had some issues, which I will keep for the next talk. But over the years, it improved. The biggest problem was that it was still the same MySQL or Postgre, pretty much the same, just with the replaced storage. But with all the issues these databases have, if there is a bug in MySQL, there is a bug in Aurora, if it's in a compute operational part. So it didn't jump to the next level, okay? It was just that same level, but in the cloud, and operated by someone else. Aurora serverless. There was serverless v1. And then now we have this serverless v2. v1 didn't succeed because it didn't scale from the size that it, if you operated like a 16 gigabyte database, it couldn't scale up to 32 gigabytes or more CPU, stuff like that. It was actually working in a way that it created another database and then copied data to another database and then switched the router to move, switched the router to go to another database, and that's it. What was the way they achieved this serverless thing, okay? But serverless v2, it's another beast, okay? It runs on something called Caspian in internal AWS language. That's one of the fundamental services I was talking with Emra that can really change the things, because it's a new hypervisor that can help virtual machines scale up and down in terms of CPU and memory. You know, if you now run VMware, you cannot add 16 CPUs or 32 gigabytes while it operates. So it's another thing. You know, it's hard to achieve. So this is one of these fundamental things that can help all the services that run database in AWS to scale. For example, Redis or Valky, they call it now, or whatever service it is, like OpenSearch or something, you know. If your Linux all of a sudden gets another CPU, poof, you can just use it, you know. That's a great thing. So what Aurora gave us is that if your SQL queries want more CPU, want more memory, it will just immediately scale up. So you define minimum and maximum. You don't operate on in terms of like CPUs. You operate in something which they invented call it Aurora capacity units. So you define, okay, it's about 2 gigabytes and some CPU, and it goes up and down. You define just the minimum and the maximum you want to pay. Okay. For me, excellent product, although it can only scale one node of a relational database. Okay, it cannot scale, it cannot jump to another node, or something like that, do some extra magic. It can just go up and down. Okay, it can scale to 0 after like this reInvent or something like it was announced, so it can scale to 0. So that means that you can run your WordPress website on MySQL. If you have no visitors this month, you pay 0. Okay, maybe a bit for the storage, but that's not a big deal. And if you get some traffic all of a sudden, it will take a couple of seconds, 10 seconds, maybe 15 seconds, 5 seconds, depends. I'm very happy with the cold start of Aurora serverless. Excellent. I didn't see that in any other cloud provider. Nothing similar. Okay, so it's a great product. Okay, the biggest problem for me was that, okay, I can switch my current database to work with this, but it will using this will be far more expensive. We calculated that it's about 4 times more expensive than using the typical Aurora instance. So we didn't switch for everything. We switched for development, testing, low traffic sites, and stuff like that. So it's a very good product. Okay. Next thing, Aurora Limitless. The problem with the previous product is that it can scale only up and down. It cannot scale horizontally. So what they gave us now, this opportunity to say, I will keep cats on one server, I will keep dogs on another machine, and when you define the table, you define how it will split the data, and the system will immediately create 2 separate instances which will handle different shards. Okay, just look for sharding. Okay, so shard keeps cats on one machine, dogs on another machine. You have every shard, you can think of it like a separate serverless V2 instance. So if you look for dogs so much, it will just scale up only that shard. You will spend resources on that shard. The dogs will not be touched. Okay, so what you define is the total amount of ACUs that you will use on this system. You know, so it will go up and down if it needs to go up and down. Okay, going up and down is very fast. That's why this product is good. And I mean serverless V2, and this is very good. So problems. Well, sharding is not easy. You need to copy if you want to do joins between different shards. It doesn't happen on a single machine anymore. It has to happen here on the router. So you have to join 2 things from the 2 different shards. It has to go to the router. The router will join this data and send it back to the customer. So it can be a bit more complicated. There is some level of Postgres in the router because of that. Okay, so query processing and stuff like that. So things can be expensive to run, complicated to run. But this is one of the things you have to think about now. If I have different customers in my SaaS solution, if I keep different customers in different shards and keep tables for one customer and data for one customer together, then with all the queries, most of the queries would just attack that single server. So it is safe. So sharding is good if you have a good shard key. Okay? One of the things that is also mentioned here is that in order to run transactions across shards, it has to use some mechanisms called distributed transactions. It's complicated. You know, it's hard and complicated. It can be tricky. So you get something, but you have to think now that sometimes it doesn't work the way you want, you know. And that's something that if you want serverless, you as a developer, you don't want to think about that. You just want to use it. Well, that's something where the serverless fails. You know, there is no way that they can make a service that we will not think about, you know. Like I always imagined, like in Lambda, I will never say how many CPUs or memory I want to use, stuff like that. But then, you know, when you face real stuff, real limitations, well, you know, in order to get the perfect thing, you need to say something. You need to adjust the service to what you want. Okay, so what they invented now is Aurora DSQL, distributed SQL. It's in preview. You don't choose anything. I mean, in terms of like how many, whatever. The only thing you can choose on the main page to create the cluster is to pick, is it single or multi-region cluster? And it has sharding, but sharding is automated by the system. It promises to be smart enough, you know, to do shards for us. Well, it can work, but in most of the cases, customers know better how to shard their data. Okay, but if you have many shards, it can be very hard for you to define the proper way to distribute that thing. So they're doing that for us because it's better for them. to do that job. You know, like it's not like they're thinking too much about us. You know, like I will always put my cats and dogs in a separate chart, but they will just pick the primary key and do something with that. So you can influence it by adding columns to the primary key, but it's not up to you. Okay, you don't really define totally what's in the chart. So in a single region, these are the services they have. First, when you connect to that database, you hit the router. It's just like a machine that accepts Postgre binary protocol. No MySQL here again. Then it goes deeper. It starts a Lambda. Lambda for a session. Session is when you connect. One session in DSQL can last 1 hour. During that time, you can run many things, you can commit many things, you run 1 hour. That's it. Okay. Okay, there are some complications regarding token duration, but for the session you get 1 hour, that's your time. Okay. So you get some service where you hit, when you hit this the compute layer, they start Lambda. Okay, sorry, Lambda service starts Firecracker. I still have some dilemmas about that 1 hour and 50 minutes and how these things relate in these things, but you know, documentation is very complicated these days. So in some places they say they start virtual machine through Firecracker. In some places they say they use Lambda service, but it's tricky. Okay, maybe the boss can say more things about that. Anyway, what they clearly say is that they start the Firecracker virtual machine with Postgre. And that's a preloaded Postgre, and you get the Postgre. You attack the Postgre. You can make a question about the data. Okay, so what that layer does, it tries to go deeper. If it reads, it goes directly to data. If it writes, it has to go through some levels called adjudicators that keep log to transactions. I will tell more about that later. And at the end, they'll hit the storage layer. Storage layer has, again, two things. One is journal, which keeps kind of log of everything. And another is like a final storage. It's a smart storage again. It's not like a hard disk. Okay. What does it mean, smart storage? So if you have data in a smart storage, you keep it organized in a way that it can help you get some answers better. Typical Postgre database doesn't keep organized data. It keeps data in pages, like 16 or 8K pages. And you have to find data to get there, okay? In smart storage, you get data organized in a table. So if you have 10 shards, you can run a parallel query and ask, give me the total of some column through all the shards. So you can hit 10 shards in parallel, 10 shards can get, storage can get the total on a column, okay? Storage is a database also, it's smart. It's not just like standard hard disk, okay? So you can parallelize queries, you can get many, many, many more things with the, what, 5 minutes? Okay, I'll become fast. So you can run in single region, you can run in multi-regions, multiple regions. The good thing is it's synchronous. If you do write in one region, it will automatically do write in another region, so you will get data there. It's not asynchronous, it's not eventually consistent, it's consistent. Okay. So, for reads, it goes pretty much directly to storage. For writes, you do your stuff. You have a transaction, you do your stuff. All the stuff that you do during the transaction, it happens locally. It doesn't go to any server, doesn't go, to that query processor, but doesn't go to that final stage of storage or something. You just do that locally. Once you decide, okay, I'm done, I will commit this data, system will send this data to this component called adjudicator, and then adjudicator will decide, can it save that data or not? Okay, so you are pretty much safe with no logs till the final commit. So, which the problem is with databases is you have to go deeper. You know, you have to understand that they work in different levels of isolation, and you as a developer, you have to know how transactions work. For example, in this case, I made this kind of a timeline that says like when things started and when they ended. So the problem is like, if you run a transaction, you have to understand that it's not only you that you're running something. Someone else is also doing some job. So it really matters what other people see and what you see during the transaction. So there are different levels of isolation. They choose to use something they call snapshot isolation, which is very similar to something called repeatable read, which says that when you start the transaction, there is a snapshot of the system, and till the end of transaction, whenever you read data at the time the transaction started. Okay, there are other isolations, for example, read committed, where you can, in this case, for example, this transaction should be able to see what other transaction committed. Okay, so it has impact on developer who's doing stuff here, but in DSQL it's a good thing because in many cases transactions don't really hit into each other. Okay, so they decided to choose optimistic locking, where they believe that there's not going to be a conflict at the end. So they pushed the final conflict to the commit stage. No locks during the transactions, which means in order to achieve this thing in a typical relational database, all the reads, all the things that happen during the transaction would invoke some kind of a lock at some point. In DSQL, there are no locks till commit. So pretty much any machine you do whatever you want in your session, and no one knows about that till you commit. On the commit moment, if there is a problem, okay, someone has to give up, and you'll get some error, okay? And if you don't hit each other, if you work on one customer in one session and another session works with another customer, you are pretty much fine. So you will not hit. So it's many things, many benefits, but the lack of need for the coordination between services is one of the biggest thing that AWS achieved. So there's the number of network calls, number of storage calls during this transaction is minimized. So the system can be simple. It's still not totally simple, but very simplified, which means that it can really scale. Okay? So one of the things that they use to achieve this thing is one of these things where AWS really makes it that's why AWS is the best. Okay, so on every EC2 machine, you should be able now to have a super accurate clock. And the timeline that I made with this red line, in DSQL, these are not numbers that go in a sequence. This is actual time. So there's no need for coordination about the numbers, like what is the next number in the sequence, where am I, and so, et cetera. So they're using time. Every single independent machine has time component with no need to coordinate itself with another machines. So it's another big thing, like that's how it benefited, So you can use it to make your own database and similar stuff. Okay. So try to be faster. I will not go into totally details about this. Give me 2 minutes, please. So, but developers need to think about these things. Okay, things that worked in Postgre because of snapshot isolation will not immediately work here. Some things cannot work here. Okay, this is one of the examples with reserving tickets, where if I just want the next one, which is not locked, if we don't see in our transaction what's going on in another transaction, we don't know what's locked. So we'll try to hit the same row in the database. So that's a problem, Some things will just not work. And with this technology, they choose to build the service now, it will not work. Okay, so who knows, maybe they will change some things in the future. Okay. So, developers face some problems, like they need to handle retries. It depends of your usage, of how data is split in your system. It may happen that you will have more retries. But if you are developers, you don't handle retries, or you don't handle transaction logs, stuff like that, you're already in trouble in some way. Okay. So also, try to keep things simple till they improve it, but they will get there. Okay. So don't use so many complicated stuff. Don't make big transaction stuff, and you'll get all the benefits. Connecting, it's not a big deal. But you just cannot connect with your username and password like you did in Postgre. You need to call AWS system. You will get a token, and then you will get, you can use that token as a password, and that's it. Okay, some limits. I'd say that these limits are now like they can be moved in many ways. Like some of these things are there for good, some of these things are just for the moment, but already some stuff is great, like a number of connections per cluster. If you're an unfortunate Postgre user, I'm a big fan of MySQL, you will be surprised with the number of connections you can do to your new database. It's like unlimited almost, you know, in what Postgre was doing to you before. So some limits, but we'll see what will happen in production. Also, like other issues, at the moment, system doesn't support foreign keys, views, triggers. I don't know. It can be hard to migrate your current application. Okay, if you want to use some of this stuff. Pricing, we have no idea, but we'll see. Okay. I just hope that they will not pick the solution to calculate everything that they spend on the system and to bill us for that, okay? We would like to have something like a $5 VPS machine and a fixed price for whatever we use. It can be, I hope it could, if it's too much, it could be slower, but you don't charge me too much, okay? I know it's hard, so. For comparison, check for the Google Spanner. They made some decisions which are making it far more complicated than DSQL is. So I think the decisions the team made were very good. Okay, skipping. Is it the best database?
Yeah.
Okay, you see that there's no one thing, you know, that you can be the best, but still you can be the best, you know, even if you're like third in this, fourth in that, blah, 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 stuff.